Welcome everyone. I am Avinash Sahu and today we study about the chapter motion. Motion is a very important chapter of physics. Okay, so one by one we study it. Its flowing topics. First of all we study about the term rest, then we understand the term motion, reference point, after that we study about types of motion, which is in which we study about uniform motion, and finally non-uniform motion. Okay, and finally non-uniform motion. So in this chapter we study about rest, motion, reference point, types of motions, in which we study about uniform motion and non-uniform motions. We also study the relation between rest and motion. Okay, so one by one we study it. So first of all we try to understand the term rest. Okay, so our first point is rest. So when a body is said to be at rest, then you consider an example. Suppose that there is a tree and we found that a stone is placed near a tree which is at, suppose that it is 2 meters far away from the tree. Okay, then when it is said to be at rest, okay, this stone is said to be at rest when it does not change, their position. I am saying that the position of the stone is at A, which is 2 meters from this tree. Okay, this is the position. This A is the position of the stone, and it does not, this position is not changed by stone, then it is said to be at rest. Okay, then this stone is at rest when it does not change their position with respect to surrounding, with respect to this tree. It means, as well as you also say that when does not change their position, okay, position is not changed by this stone. And another term is time. Okay, suppose that you see a stone at 9 o'clock, okay, 9 o'clock AM. Then after 1 hour, it means 10 o'clock, you found this stone is at the same position. Then after 3 hours, it means after 3 hours, it means you found it after 3 hours, it means at 1 PM you found that it is again at its previous position. Then and so on, time is changed. Here time is changed, but it does not change their position. So this stone is said to be at rest. Okay, so how we define rest? You define rest as follow. You define rest as follow. Okay, define rest. The object is said to be at rest. The object is said to be at rest when it does not change their position. If it does not change their position with respect to sometimes with respect to write as WRT, it means with respect to. Okay, sometimes we write it as WRT. WRT means with respect to. Okay, the object is said to be at rest when it does not change their position with respect to time or surrounding. Time or and you can write it and surrounding. Okay, here time means you observe it with respect to time, then you found that it is at same position with respect to this tree. It means remained at position A. It means it is, or when the time changes it remains at position 2 meter. Okay, it does not change their position with respect to time or surrounding. Surrounding means it is remains at its previous positions with respect to time, with respect to position, surrounding or time, or right here, or with respect to time or surrounding it does not change their position, then it is said to be at rest. Okay, give some more example of rest. Okay, give some more example of rest. What happened sometimes, what happened, you found that some example of rest. Okay, sometimes you found that when you put books on a table, then remain it is as rest. So example are books on the table. Okay, on the table. Number 2 is car in parking area. Okay, stone near the tree or near anything near your home. Okay, we take here example tree, so I am right here tree. Stone near the tree. Okay, these are the example of rest. So what is rest? A object is said to be at rest when it does not change their position. It is, if its position is 2 meters from the from T, then it is said to be at rest. Okay, then it is said to be at rest. So you tell me, what is the definition of motion? What is the definition of motion? Next term is motion. Next term is motion. Okay, tell me the definition of motion. How we define motion? Okay, how we define motion? How we define motion? Okay, so take an example that there is a tree. Okay, there is a tree and you are, suppose this is you, you are here at position 2 meter, at position A at 2 meter. If you remains at this position, then it means you are at rest. But what happened when you start walk and you reached at position here, at position B, which is 5 meter from tree. Then what happened? Okay, then what happened? Actually, you are at position A, but after some times you walk and reach at position B. Then this is said to be in motion. I am also in motion. Okay, what is motion? Motion is said to be when an object change their position with respect to surrounding. This tree behave like a surrounding. Okay, this tree is behave like a surrounding. Okay, so what happened when if a person is walk around any path, then it change their position, then it is said to be in motion. With respect to surrounding or time. Okay, with respect to time or surrounding, because you suppose that at 9 o'clock you are at position A, but after 20 minutes, after 5 minutes you reached at position B. Then what happened? Then in 5 minutes you travel 3 meter distance. Okay, it means you are in motion. Okay, it means you are in motion. You can take another example also. Suppose there is a car. Okay, suppose there is a car. Okay, suppose there is a car and car is moving. Okay, and car is moving on the road, then it is said to be in motion. Then it is again said to be in motion. If a car is moving, then what happened? Then it is said to be in motion. Okay, you can take another example of motion is, you found that a train is moving on the track, then it is also in motions. A bird is flying in the space, in air, then it is also in motions. Okay, so these are some examples of motion. Okay, so how we define motion? Motion is object is said to be in motion. Take in motion, I change in the previous definition. Okay, at rest, in place of at rest we write here it motion. Object is said to be in motion when it change their position, with respect to time or surrounding. With respect to time or surrounding. So, okay, the object is said to be in motion when it changes their position with respect to time or surroundings. Okay, so an object is said to be, in motion. Okay, so this is the definition of motion. Now come to the point, what are the relation between rest and motion? Rest and motion are relative terms. So what it means, we understand this line, this statement by this example. Okay, by this example. Okay, so suppose that there is a building on earth. Okay, there is a building on earth and you observe it, then you says that this building is at rest. This building is at rest. But when you observe it But when you observe this building, okay, but when you observe this building from other planet or from space, okay, when you observe it from other planet or from space, then what you found, then you know that our earth is continuous, is in rotation, okay, our earth is rotating continuously, our earth is rotating continuously. Suppose this is the building, okay, suppose this is the building and you observe it from the earth, then you found that this building is at rest because it does not change their position with respect to other tree or with respect to other building, okay. But when you observe it from the other planet, okay, then you found that this earth is also continuous in motion, so it means it continuously change their position. Suppose that you found that initially its position is, but after some time its position is changed because it continuously is in motion. Our earth is continuously in motion, so this position is changed and reached there. It means starting position here and after some time its position, building position is changed. So at the same time object are in rest, or at the same time this is in motion, this is in motion, okay. So you can say that there is nothing like absolute at rest. It means if you think that this body is at rest, then if you observe from other planet, then it is, you found that it is in motion, it is in motion, then you can say that this is at, so you can say that rest and motion are relative term. Relative terms means one thing is at rest, at the same time it is in motion for others, okay. You can take another example also. You can take another example, okay. Whenever you travel in a train, okay, whenever you travel in a train, then you found that two passengers are seated to each other, okay, then two passengers are seated to each other, then this person says that this is at rest because its position does not change with respect to time. When you are in a train also, when you are also in train, then you found that this person is at rest with each other, okay, because it does not change their position with respect to other passenger, then it is at rest. But a person which is outside the train and train is moving, then you found that this person is also moving with train. It means he found that initially its position at this, but when he observed that it continuously in motion, then this person is motion for the outside passenger, outside person, okay. It means a person who are standing on the road and train is moving, then this person are in motion, but with respect to each other they are at rest, okay. So rest and motion are relative terms. So rest and motions are relative terms. It means, so rest and motion are relative terms. It means a person, a object is at rest for someone, at the same time it is in motion for other, okay. So you can say that rest and motion are relative terms, okay. Our topic is reference point. Reference point. what is the meaning here reference point? Okay, so start it. Suppose to define rest or motion, to define rest and motion, you take a tree. Okay, you take tree that its position is at 2 meter from this tree, Okay, so listen carefully. To study the term motion, it is very important that we take a point from which we study the motion. Okay, for example, it is at rest or it is in motion. For it, we observe it from this tree, that its position from this tree is continuously at rest, then it is motion, then it is at rest. And if change their position with respect to this tree, then this tree is known as reference point. Reference point means a point or fixed position from which we study fixed position or point with respect to which the motion has to be studied. Okay, the motion has to be studied. Reference point, a fixed point or position with respect to a fixed point or position with respect to motion, with respect to motion has to be, with respect to motion has to be studied, then has to be studied, then this fixed point or fixed position, this fixed point or fixed position is said to be reference point. Okay, is said to be reference point. Simply you can say that reference point is what? Reference point is a position or a point from which we study about the motion. Okay, you can say that you are placed, suppose you are here and study that this object is motion or rest, then this is point, then this fixed point, but this point should be fixed, it does not be changed. Okay, so this fixed one, so it is at, take those example which is at rest, for example building or tree from which you study about study the motions, then this building or tree is said to be, then this building or tree is said to be reference point. Okay, in our previous example, tree is the reference point because we take distance, we take position. Okay, because this tree is, firstly it is at fixed, it does not change with time, so this is represented by the symbol O. O is reference point, or sometimes its other name is origin. Okay, origin. Okay, origin here means there's a, you can say the reference point or origin, and a fixed point or a position with respect to motion has to be studied, then this fixed point or position is said to be reference point. Suppose the object is here and after some time moves here, then it changes position from A to B. Okay, from where you observe its position is A from O, then this O is reference point or origin. Okay, this is reference point or origin, this is reference point. Okay, then this fixed point is said to be reference point because we observe it from, it is 2 meter or it is 5 meter, then what it means, from, we observe it from this tree, so this tree is fixed point. Okay, this is known as reference point. Okay, now we understand the term uniform speed and non-uniform speed. Okay, types of motion in this types of motion we study about. There are two types of motions. Okay, number one is uniform motion, and number two is non-uniform motion. Okay, so first of all we study about the term uniform motion. Okay, take an example so that you understand it. Okay, take an example. Suppose that this is time t, okay, which is measured in second, and here is distance d, which is measured in meter. Suppose that from reference point O, a position is at position of the object is at A, which is 2 meter from reference point. Okay, a object has position at A, okay, not say 2 meter, take 10 meter. Okay, then we found that the position of this object is 10 meter from reference point, from fixed point, which is reference point. Okay, is 10 meter at A position. It covers this distance in 2 seconds. Okay, it means initial time is 0. When it starts its journey, then time is 0. But after 2 seconds, it reaches at position A and cover distance 2. It means time taken by the object is 2 seconds. In 2 seconds, object covers 10 meter. It means initial time is 0. After 1 second, it covers 5. Then after 2 seconds, it covers 10 meter. Then we found after again 2 seconds. After 2 seconds, it means here its position is 2 seconds. Okay, or you can say that when it reaches when the object at position B, which is 20 meter from this tree. Okay, when this object covers 20 meter, then time is spent 4 seconds. It means to reach from tree to point B, object takes 4 seconds. Okay, after some times it reached at position C, then it takes distance covered by it from the tree is we found is 30 meter, and the time taken to cover from tree to this, then it is 6 seconds. Okay, then it is 6 seconds. If we draw the table, then I found that this is at 0 when at 0 it is at position 0. It does not cover any distance. After 2 seconds, it cover 10 meter distance. After 4 seconds, it cover 20 meter distance. And after 6 seconds, it covers 30 meter distance. Then what is the relation you found? You found that in equal interval of time means what is the time taken from 0 to A to B, B to C. After interval, how you can get time interval? How much time taken to from O to A? How much time it take from O to A is time interval T2 minus T1. It means 2 seconds. Okay, from origin to A, it takes time 2 seconds. Then how much distance it covers? It covers 10 minus 0. It means 10 meter distance it covers in first interval. Okay, in second interval, from A to B, how much distance it covers? It covers from A to O, A, B, C. Okay, then A to B, how much distance is covered? A to B, if this is 10 meter and this is 20 meter, then how you get this distance? 20 minus 10, it means again it covers 10 meter. Again it covers 10 meter distance in how much? What is the time interval? What is the time interval here? 2 seconds. Again 2 seconds, because it takes 2 seconds, then it time is 4. It means time interval is 2 seconds. To cover A to B, it takes 2 seconds time. Okay, so it takes 2 second times. And from B to C, what is the time? Time is taken by from B to C is 2 seconds. B to C, if I am talking about O to C, then it is 6 seconds. O to B, then it is 4. But if I am talking about B to C, then it is take 2 seconds. Similarly, from B to C, it takes 2 seconds. Then how much distance it cover? Distance is 20 meter and C distance is 30. Then distance from B to C is again 10 meter. Again 10 meter. It means object is said to be uniform motion when it covers equal distance in equal interval of time. Okay, object is said to be uniform motion when it covers equal distance in equal interval of time. Okay, when it covers equal distance in equal interval of time. Okay, so write the definition here. An object is said to be in uniform motion when it covered equal distance in equal interval of time. Equal distance in equal interval of time. Okay, this is an example. You can draw it the diagram also. Okay, you can draw it the diagram also. When object covers equal distance in equal interval of time, then object is said to be uniform motion. Okay, uniform motion. Okay, so take an example. Okay, take an example. I will give only right here only one example. It's your turn that you write minimum 5 example of uniform motion. You can say that if a train is traveling, if a train running on the tracks with 180 km per hour, then it is track running with 80 km per hour with steady rate, with steady speed, with steady speed. What is the meaning of here? Steady speed. Steady speed means uniform speed, same speed. There is another name of uniform motion is constant. Constant means same speed. Constant motion, same speed. Okay, constant motion. It means object covers equal distance when it travels, when it moves with a constant. constant speed, same speed, uniform speed, okay, then object is said to be uniform motion. So I'm writing here an example. If a train running on the tracks with steady speed, and that speed is 180 km per hour. If a train is moving with the same speed, it means here the speed is 180 km per hour, here is also again the speed is 180 km per hour, then object is said, then train is said to be in uniform motion. Or what is the, I think now you are able to give the definition of non-uniform motions. Okay, non-uniform motion. Okay, now I think that you are able to understand non-uniform motion. If an object is said to be non-uniform motion if it does not cover equal distance and equal interval of time. Suppose in case of this, if time is 0, if after 2 seconds it is positioned at 10, but after 4 seconds its covered distance 50, and after 6 seconds is positioned at 200, then what you found, at equal interval of time you found that it covers unequal distance. For example, in first case it covers 10 meter, in second case it covers 40, and in third case it covers 150 meter distance. It means its speed is different. Sometimes its speed is fast, sometimes its speed is slow. Example of non-uniform motion is when anyone is driving a car in traffic area, then what happened? Then sometimes speed is slow, sometimes speed is fast, sometimes it is at rest. That it means its speed is varying. So it is another name of non-uniform motion is varying speed, different speed. Okay, when object moving with varying speed, so varying means different, variable motion. Sometimes it is said to be variable motion. So what is the definition of non-uniform motion? An object is said to be non-uniform motion when it does not cover equal distance in equal interval of time. Suppose suppose a body is at origin, after 2 seconds it reaches at point A, after 4 seconds it reaches at point B from tree, after it is at position 6 seconds, okay, at point C, then we found that its position is 10 meter, this position is 50 meter, okay, and this position is C position is 200 meter. Then how much distance it cover from this is 10 meter, 10 minus 0. When it is at position B 50, which how you get, this is position at 10 and this is 40, it means 40. It means here position is how much distance is covered, 40, and in this case its position is 200 and this position 50, then 150 meter. It means how much distance is covered, in this case 150 meter after very equal interval of time. It means object covers unequal distance. First times it covers 10 meter in 2 seconds, then 40 meter in 2 seconds, then finally it covers 150 meter in 2 seconds. So what you found? You found that at equal interval of time it covers unequal distance. So it is said to be non-uniform motion, variable motion, variable with different speed. When body moving at different speed, then it is said to be non-uniform motion. Okay, for example, motion of a car in traffic area. Okay, so this is the example. You also write some more example of non-uniform motion. Okay, so this is the topic about motion in which we study about the term rest, motion, relation between rest and motion. Finally you understand the term types of motion, which uniform motion or non-uniform motions. Okay, so thank you very much.